The James Webb Space Telescope, JWST, has made a discovery that could reshape our understanding of the universe. From a planet located light years away, it detected beams of light that appear to radiate like those from a city, prompting speculation about the existence of intelligent extraterrestrial life. The telescope focused on Proxima Centauri B, the nearest known exoplanet to our solar system, and observed strange, brilliant flashes of light. Could these luminous signals be the work of an alien civilization? The finding has reignited global fascination with the possibility that we are not alone in the cosmos. For decades, scientists and dreamers alike have pondered life beyond Earth. But this moment feels pivotal. The James Webb Space Telescope has now provided the clearest indication yet of what could be artificial light coming from a distant world, suggesting the presence of an advanced, possibly city-like structure on the surface of Proxima B. This extraordinary observation has sent waves of excitement through the scientific community. The implications are staggering. Intelligent beings might be operating civilizations far beyond our reach, yet now within our view thanks to the JWST's advanced capabilities. NASA engineers were stunned by the observation. City-like glows visible from 4 light years away. These lights might have been shining for decades, even centuries, just waiting for humanity's instruments to evolve enough to notice them. David Kipping, an astronomer at Columbia University, described Proxima B as an unusually complex planet. Unlike most rocky worlds, which absorb light and re-emit it as infrared radiation, Proxima B shows peculiar behavior due to its tight interaction with host star Proxima Centauri. The JWST's unmatched ability to capture infrared wavelengths has been critical in revealing these anomalies. This capacity enables scientists to study Proxima B's atmospheric and surface conditions in unprecedented detail. Researchers now plan to delve deeper, analyzing the planet's atmosphere to determine whether it could sustain life. What sets JWST apart is its sensitivity to faint infrared light. Where other telescopes struggle in the vast, dark void of space, JWST excels, capable of detecting even the dimmest artificial glow. This makes it the perfect tool for confirming whether these suspected lights on Proxima B's night side are truly signs of extraterrestrial technology. The telescope can differentiate artificial light sources if their frequencies fall within a narrow, detectable range, separate from the broader emissions of stars. This precision allows astronomers to examine the planet with greater confidence. Proxima Centauri B has a dynamic relationship with its parent star. It endures cycles of intense stellar radiation during its daytime and frigid conditions at night. If the planet has an atmosphere, the contrast between its day and night sides could be extreme. This wide temperature range is a key focus for astronomers, offering vital clues about the planet's composition and climate. Thanks to JWST's infrared imaging capabilities, scientists can study Proxima B's thermal emissions, unlocking insights into its atmospheric characteristics. Interestingly, JWST's orbit around Earth aligns in such a way that it can monitor Proxima B's daylight cycles, about every 11.2 Earth days. If Proxima B indeed possesses an atmosphere, the next step is to analyze its chemical makeup. Detecting gases like oxygen, methane, and water vapor will be essential in assessing its potential to support life. The presence of oxygen, water vapor, and methane in an exoplanet's atmosphere could indicate the potential for life. Detecting these molecules involves analyzing the light that passes through a planet's atmosphere, a challenging and intricate task. While the James Webb Space Telescope, JWST, is highly capable when it comes to studying atmospheric compositions, especially detecting water vapor, carbon dioxide, and methane, it is less effective at identifying free oxygen, a key biosignature. However, JWST can still detect other critical indicators, such as ozone, which may point to a healthy, life-supporting atmosphere. As astronomers analyze the data gathered by JWST, the search for habitable worlds marches forward, bringing us closer to answering one of humanity's greatest questions. Are we alone in the universe? It's important to recognize that JWST is limited to observing only a select number of exoplanets relatively close to Earth. For more detailed atmospheric studies, astronomers are looking ahead to the capabilities of ground-based observatories like the Extremely Large Telescope, JWST, which is scheduled to become operational in 2027. The ELT will offer unparalleled insight into the atmospheric structures of distant exoplanets, providing more detailed and clearer data on their potential habitability. Despite its limitations, JWST remains an essential instrument in our ongoing exploration of the cosmos. Its contributions are paving the way for future space telescopes that aim to reduce the glare of starlight, an obstacle that makes observing exoplanets particularly difficult. Much like shielding your eyes from the sun with your hand, new telescope designs will use advanced techniques to block out starlight and focus on the faint light reflected from exoplanets, allowing scientists to better analyze their atmospheres for signs of life. But this task is anything but simple. Stars are immensely bright, often outshining their orbiting planets by many orders of magnitude, making it extremely difficult to detect the faint reflected light crucial for atmospheric analysis. To overcome this, scientists are developing innovative technologies. One approach is the use of coronagraphs, devices inside telescopes that block the overwhelming light from a star while allowing planetary light to pass through. By manipulating the light wave precisely, coronagraphs can suppress starlight significantly, making it easier to spot the dim glow of exoplanets. Another promising technology is the star shade, a large, flower-shaped spacecraft that operates in coordination with a space telescope located tens of thousands of kilometers away. The star shade blocks starlight before it even enters the telescope, enabling only the light from exoplanets to reach its detectors. This method is especially promising for observing planets in the habitable zones of their stars, where liquid water and potentially life might exist. However, these technologies require extraordinary precision. For example, a star shade must be aligned with near-perfect accuracy, within fractions of a millimeter, over vast distances. In addition to alignment challenges, these instruments must be engineered to withstand the harsh environment of space, remain energy efficient, and be compact enough for launch. Despite these obstacles, the potential scientific rewards are immense. Successfully analyzing exoplanet atmospheres could lead to the discovery of biosignatures, specific ratios of molecules like oxygen, methane, and water vapor that suggest biological activity. Researchers are also working on ways to directly image distant planets in greater detail. Future telescopes may use adaptive optics, systems that correct for distortions caused by Earth's atmosphere or spacecraft movement, to produce sharper images. When combined with starlight blocking methods, these innovations could dramatically improve our ability to detect and study Earth-like worlds. Emerging advancements in space technology are poised to do more than just detect exoplanets. They could soon allow scientists to map their surfaces and analyze their climates in detail. The development of next-generation space telescopes marks a monumental leap forward in humanity's search for answers to one of its deepest questions. Are we alone in the universe? By enhancing our ability to observe distant worlds, we are inching closer to discovering whether life exists beyond Earth, a possibility that could dramatically shift our understanding of our place in the cosmos. The pace of space exploration is accelerating like never before. As researchers probe deeper into the mysteries of exoplanets, the James Webb Space Telescope JWST is ushering in a new era of cosmic discovery. JWST's observations are already providing groundbreaking insights into the structure, composition, and potential habitability of faraway planets. With each new dataset, we edge closer to uncovering the ultimate truth. Is there life beyond our planet? The discovery of Proxima Centauri B, the closest known exoplanet to our solar system, could be a defining moment in the search for extraterrestrial life. This planet has long been the subject of intense research. Until now, however, hopes of detecting concrete signs of life, such as artificial light or indicators of civilization, seemed out of reach. But with the James Webb Telescope reportedly picking up possible signs of such light, the scientific community's hopes have been reignited. Could this be our first glimpse of intelligent life beyond Earth? These discoveries not only captivate scientists, but also ignite the imagination of the public, inspiring future generations to look beyond the boundaries of our own world. While the JWST continues to search for artificial signals, it's also examining exoplanet atmospheres for vital chemical signatures, such as methane and carbon dioxide in life-supporting concentrations. These atmospheric biomarkers are essential in determining whether a planet could sustain life. What sets JWST apart is its unprecedented ability to analyze these components in exoplanet atmospheres, offering clarity like no other telescope before it. This opens a window into the conditions of distant planets and whether they might resemble Earth in any meaningful way. One of the most intriguing features of Proxima Centauri B is its position within the habitable zone, the orbital region around a star where temperatures are just right for liquid water to exist. Since water is fundamental to life as we know it, planets in this zone are prime candidates for further study and future missions. However, habitability isn't just about distance from a star. Many exoplanets, including Proxima Centauri B, may be tidally locked, meaning one side of the planet always faces a star while the other remains in constant darkness. This could lead to extreme temperature differences and potentially hostile climate conditions. Understanding such planetary dynamics is crucial for evaluating whether life could realistically thrive there. Technological advancements are also helping scientists overcome one of the greatest observational challenges, blocking out the bright light from stars. Without this capability, detecting the faint light reflected off distant planets would be nearly impossible. Tools like coronagraphs and star shades are revolutionizing the field by filtering out starlight, allowing telescopes to capture subtle planetary reflections and unlock critical data about their environments. Another major breakthrough is the concept of direct imaging of exoplanets. By combining adaptive optics with starlight suppression techniques, astronomers aim to capture high-resolution images of planets as they orbit their stars. Such images could reveal surface features like oceans, continents, or even dynamic weather systems, offering unprecedented detail about alien worlds. These imaging technologies represent a quantum leap in our ability to explore planetary systems and evaluate their capacity to support life. As the search intensifies, the James Webb Space Telescope and future missions inspired by its success will remain vital. Thanks to its ability to detect faint planetary signals, analyze atmospheric elements, and uncover signs of habitability, JWST is reshaping our view of the universe. With rapid technological progress and growing scientific insight, we stand on the edge of discoveries that may forever change our understanding of life in the cosmos.